Right. Welcome back to the advent of Fortran. Today, I'll be working on day 17, but before I dive into that, I'll give you an update on the last few days. So, the last video that I recorded was day 8, and I did record a video for day 9, but unfortunately I didn't record any audio, so that's a bummer, man. Uh, And then I didn't even attempt to record videos for days 10 through 16. It was the work week anyway. Uh, but I did finally get caught up almost to solving each puzzle on the day that it's released. Uh, Days 9 through 15 went fairly well. The code is all here. Feel free to check that out. There's going to be a link in the video description. Uh, day Day 15 was a little tough. I I didn't figure out some of the optimizations, so my code took like 3 hours to run, but it did eventually give me the right answer. Day 16, I had even more trouble. I've only figured out part one so far, and my code for part one is actually still running here, but I'm also having it print out the best answer so far as it goes. Uh, and I can tell from the number of permutations that this is about 2/3 of the way through so far. So there was a good chance that this is the optimal solution anyway, and it turns out that it is. So that's part one. I might go back and work on part two. I only got this answer to part one entered in this morning, but I decided to prioritize day 17. So let's dive into that. I already read this description last night right before I went to bed. If there's anybody out there who's actually working on these at midnight, y'all are crazy. Like, I'm not going to do that to myself. I'd rather be sleeping. So basically, we're implementing Tetris, except Tetris only has 4-piece blocks. This has a 5-piece block there, and a 5-piece block there, and then it has a couple of the Tetris blocks as well, like the square shape and the line shape. But this is Tetris without rotations, so we don't have to worry about rotating these parts. We only have to we only have to worry about moving them left and right according to this input to the puzzle. And they alternate between moving down by one block and then moving left or right by one block according to this input list. And then they move down again, then left or right again until they hit the bottom. Like this example, they show the horizontal line piece hits the bottom, and then each new piece spawns so that there are 3 blank spaces between the top of the last piece and the bottom of the new piece. And in terms of horizontal alignment, it spawns so that there are 2 empty spaces between the left side of the piece and the left wall. So part 1 at least should not be that bad, at least if you're a little bit familiar with Tetris. So it's basically Tetris without rotations and with a couple differently shaped pieces. And they want us to simulate 2022 Tetris blocks and then count how high the tower of stacked pieces is. So let's get into it. This is day 17. This is the example input. And let's get the actual input. Oh, and by the way, when you get to the end of the input, they have you cycle back to the beginning again. So even as we're simulating thousands of pieces, we don't run out of input here. We just loop back from the right side to the left side of the input. I've increased my font size too, so hopefully this is more readable than the last video. I did that for the attempted day 9 video too, but then there wasn't any audio. So there's the input. Just round that capacity up to a power of 2. Can I do that? I don't know if I can have multiplication in that constant. Yeah, it doesn't like that. Okay, just needed parentheses. So I want to make sure that that's long enough. It should be. This was like 10,000 and a little change, and this should be like over 16,000. So the last few characters are left, 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 4 lefts and 1 right. And that's 4 lefts and 1 right. So yeah, it looks like I'm reading all of that. Okay. Going to come back to parsing this. But to start, I want to hard code all of these shapes. So I'm going to I'm going to hard code each of these shapes as an array of its coordinates of each block, and there's going to be an x coordinate and a y coordinate. So this has a piece at x1, x2, x3, and x4 if I start from x1, which is arbitrary, but that's going to be my convention. And then all of the y coordinates have the same value. This piece, it's going to have y2 and x1, x2 and y1, x2, y2, and then x3, y2, x2, and y3, and so on for all of these pieces. So those are going to be arrays. And some of these are 4-block pieces, and some of these are 5-block pieces. So that also needs to be a separate array. So number of blocks per piece, that's either going to be 4-block pieces or 5-block pieces. So we have a 4-block piece, five-block piece, then another 5, and then 2 4s. That should still compile. Number of pieces here, we have 5 different shapes that they've given us. Okay, that compiles. So these are the sizes of each piece, and now we need to do their coordinates too. I'd like to put them all in one big array. So for the 4-piece blocks, I'm going to pad them with a couple zeros at the end. biggest pieces have 5 blocks, so that's what that parameter is. Yeah, this is going to be a rank 3 array, so 2 for x and y, NB max for the number of blocks, and then 1 more for the number of pieces. You have to do something funny here with G Fortran, which you don't have to do in Intel Fortran for a parameter rank 2 or rank 3 array. You have to reshape it in the parameter definition, which I thought I did. Yeah. And I did that in day 12, or whatever day 12 was, I can't remember. Yeah, so like here's a 2x4 matrix in day 12. So with Intel Fortran, you can have a literal rank 2 array with a rank 1 array that contains other rank 1 arrays. Like if I put more square brackets in here, you can't do that in G Fortran. You have to define it as a rank 1 array and then reshape it to a rank 2 array. So it's a little bit redundant, but whatever. If those are the G Fortran rules, I'll play by it. It's probably in the Fortran standard anyway. So, the shape of the first piece. First of all, I have to get my reshape command in here. So it's going to be x first and then y. So 1, 1. Yeah, these are all going to be single digits. So 1, 2, 1, 3, 1, and 4, 1. That's this horizontal line piece. Then the next piece is going to be this plus sign. And I need to pad this with zeros because some of the blocks are 5 blocks long. Before I do all of the pieces, just want to see if this compiles. 5 pieces, yeah. Then I have to finish reshaping that, like here. This is going to be 2 by NB max by NB. The shape down there has to be the same as the shape up here, so that's why this is redundant. But that's what you need to do for G Fortran, I guess. Okay, so that compiles. Let me print that out too. I'm not going to bother formatting it yet. Okay, so there's something in there. Now, this piece is a little trickier than the horizontal line where everything has all the same y coordinates. So if we start here, that's 2, 1, and then 1, 2, and then we have this middle row here where everything has the same y coordinate. So 1, 2, 2, 2, 3, 2, and then 2, 3 for the top. So that's that piece. Now we have this L-shaped piece, or really it's like a reverse L, and we don't have rotation in this game, so there's not going to be any L-shaped piece. So this is going to start out like the horizontal line: 1, 1, 2, 1, 3, 1, and then we go up in the y coordinate. So 3, 2, 3, 3. Now we have a vertical line. It's going to be similar to the horizontal line, but now the y coordinates are going to be changing, and all of the x coordinates are 1, 2, 1, 3, 1, 4, and then pad with zeros. Don't forget my trailing commas because it's all one big array. And finally, we have a square block. 1, 1, 2, 1, 1, 2, 2, 2. Pad with zeros. No trailing comma because that's the end of the array, but we still need to continue the line with an ampersand. I'm not going to use the word block because I'm using the word block to refer to one of these, like number of blocks per piece. That's what my shorthand means there. So that should still compile. This prints something. And they tell us that the rocks fall. This rock, they call it a rock. I'm calling it a piece. I'm thinking like a piece in Tetris. So there's going to be a difference in terminology there between what I'm saying and what the puzzle is saying, where they refer to it as a rock. So the pieces fall in this order. There's the line first, then the plus falls as the second piece, then the L, and then this piece, and then the square block. And then it cycles back to the first piece again, and it falls in the same order again every time. It's not like Tetris where the pieces fall in a randomly generated order. This is a little more predictable. Well, it's totally predictable because then, like, how could you solve the puzzle if there was a randomized element to it? Gonna format this. Is it worth it? No, I'm not going to bother formatting this. The way that I'll debug this is by printing out something roughly similar to this and seeing if it matches the example. So I'm going to want the size of this string, which is not the maximum padding of the buffer. Something smaller than that. And they want us to simulate 2022 rocks. Is this day 12? No. Yeah, day 14 had sort of a similar problem where you had things falling in space, and then coming to a rest when they hit the bottom of the space. So this is sort of similar to that. But with day 14, it was 1 pixel at a time that was falling. Now we have like a whole group of pixels. We have a whole piece that falls at a time and moves as a group. So it's going to be similar to that. There's going to be this outer loop, which loops through the pieces. And then there's going to be an inner loop, which lets that piece fall until it hits the ground or hits another piece. Right, they say that our space is seven blocks wide. Right, this is 7 wide. And then you have walls on either side of that. Yeah, there it is. And there's not really a height, but I'm going to put in a max height. You could do growable arrays in Fortran. You can start out with a certain height, and then if you overflow that, you can reallocate and copy. But I'm not going to bother with that. I'm just going to set an upper limit to the capacity. So let's think about this. If we have 2022 rocks, and the biggest rock is like 4 wide, or 4 high, then it could be this times 5. So I'll do that, plus a little padding, and round up to a nice multiple of 2. And then we're going to have the x and y coordinates to track the local origin of each block as it falls. So basically, we're going to track one corner of the block, and then all of the other pieces using these coordinates, these local coordinates, will track the rest of the blocks in the piece relative to its minimum corner. So this is going to be the minimum corner of the piece. That's going to get moved around by gravity and then by the gusts of wind. So it's going to move down and horizontally through time. So these are going to change in time. These are going to stay the same. And then we're going to add them up to get the coordinates of all the blocks in each piece. I've kind of implemented Tetris before. I started it as a side project, and I ended up with a few bugs. So I didn't really finish it, but I got at least this far in the implementation. So I do have a little bit of a head start here, even though it's still going to take me well over an hour to finish this, most likely. So, yeah, we're going to track it's sort of arbitrary how you index this space. This is another problem where there's no global reference frame that the problem tells you to use. Uh, so I'm going to call this pixel 1 comma 1. You could call it 0 comma 0. Or you could think of what I'm doing as calling this corner of the floor and the wall 0 comma 0, and then this is 1 comma 1. It doesn't really matter what global reference frame you use as long as you're internally consistent in your code, because the problem does not give you a reference frame. You could start indexing x from right to left instead of left to right, or y up or down. It doesn't really matter as long as you're consistent. So I'm going to call this 1 comma 1, and then the pieces will never have 0 or negative coordinates, and then I'm going to index x to the right and y up, x to the right that way. So basically, yeah, the floor is 0, and then the floor is 0, y, and then the lowest place that an actual block can be is 1. So y max rest. This is going to keep track of the top of the block, or the top of the tower of rested pieces, because when we spawn a new piece, it has to have a space of 3 blank spaces between the bottom of itself and the top of the tower. So that's how we're going to track that. And then initially, each piece, it's going to be at x equals 3, right? Because they tell us it spawns like this. So x1, x2, x3. And now, hold on, calling all of these 1, 1. So actually I want to call this, what do I want to do there? Yeah, I want to index from 0 because I'm going to add this, and then that's going to be the minimum block position. So I'll say it starts at 2. Basically, it's off by 1 now, and I don't want to do arithmetic all over the place, so I'm calling this 2. And then this can be 0, right? So here's 2, here's 1, and here's 0. But then when I add up this, the 0 is going to turn into a 1. So I can use the default Fortran indexing from 1. You can index Fortran arrays from 0, like the way C works. Actually, you can index them from any starting point, positive or negative, but the default is 1-based indexing for arrays in Fortran. So I'd like to stick with that if I don't make too many off by 1 errors. So that's the x coordinate. And then IY is going to be y max rest plus 3. So if I start with 0, add 3, and then the piece array will add another one. So yeah, 3 is good. Just trying to make sure I don't have off by 1 errors, but I think 3 is correct here and 2 is correct there. And the problem tells us it has to be 2 from the wall and 3 from a piece vertically. Yeah, and I forgot to declare another crucial piece of this problem. We keep track of the falling pieces, and then we keep track of all of the rested pieces as well. You could do that with a logical array, or I'm going to do an integer array just in case to future-proof myself because I don't know what's coming in part 2. For part 1, they just want to know the height of this tower, and you could do that with a logical array where it's like false if there's no piece that's rested there, and true if there is a piece that's rested there. So you only need 2 states for that. and a logical or Boolean array would work. But I don't know what's coming in part 2. Maybe they'll ask us, like, did this piece used to be an L-shaped piece or a square or whatever? So I'm going to make them integers just in case. So I'm going to say empty is 0. Horizontal. The rest of them are going to be in the same order as this, so this has to be consistent. Horizontal. Yeah, I'll just call it horizontal. 1. Hold on a second. All right. Horizontal plus reverse L. I don't know what to name these things. Rev L. I could name it L, but L is kind of short, and I might use that for like an integer or something else. Vertical line. Square. Yeah. Right, well, that's going to mess up my alignment. So there we go. Okay, lots of things that don't compile. To continue my lines properly. This is one of the big differences between Fortran and C. In C, you end every line with a semicolon. Lots of languages are like that, except fucking JavaScript, which is weird, where the semicolons are sometimes optional, but sometimes they're required, and you never really know whether it's optional or required. Fortran doesn't have semicolons, so a line just ends when you have a new line, unless you have an ampersand. So like in C, you have to put a symbol at the end of every line that actually ends. In Fortran, you don't, but then you have to put something different at the end of every line, which actually is an ending. So it's easy to forget that, and then the compiler complains. As it should. So... Okay, now what I was getting to is I need an array to keep track of everything that has come to rest. I'm not going to keep track of the falling piece in the array. I'm only going to keep track of things that have settled. So, and the size is going to be, didn't I put a capacity on this somewhere? Oh yeah, the size is going to be nx by ny max. And if this overflows, I'll have to change this and recompile, but that's okay. State. Tower. Rocks. I'm going to call it rocks, and it's confusing because I'm not using the rocks terminology anywhere else in here. I'm calling them pieces instead of rocks. But rocks is going to keep track of the state of which pieces have come to rest, or if there's an empty position. And that's ny by ny max. Why did that indent automatically? There we go. Okay, and this is infinite looping because I put an infinite loop there. Now we need to alternate between horizontal motion, which is dictated from the input, and vertical motion, which happens at every other time step. So first, here's the initial thing. Yeah, here's the initial thing. And then first there's a horizontal motion, and then there's a vertical motion, then horizontal, then another vertical. I'm going to use one counter for all of that. And basically on odd steps, there's going to be horizontal motion, and on even steps, there's going to be vertical motion. So I will call that J, for lack of a better name. No. Call it IT, for T as in time. Does the spawning of a new rock count as a time step? No. I don't think so. If it does, we'll figure that out when we get to it. So, basically, when the piece has not come to a rest, we're going to increment the time index. And then if it's even, there's going to be vertical motion, and if it's odd, there's going to be horizontal motion. Because on the first iteration, so this starts at 0, and then it's going to increment to 1. So at the first step of 1, that's odd. So this is odd. So at the odd pieces, at the odd time steps, we're going to have vertical motion. And at the even ones, there will be horizontal. No, this is backwards. That's what I meant to say. I just got horizontal and vertical mixed up. So the index into the input, because we have this input string s, and it's going to cycle back to the beginning after it gets to the end. So it's not going to be IT, because this skips over every other spot. So we need to divide by 2. And then we need to take that, well, no, hold on. We need to divide by 2. We need to take the modulo with the length of the string ns, and then we need to add 1, so that it's a 1-based index instead of a 0-based index. So I think that's right. And then what's the length of this string? So this should go from 1 to 40, and then it should go back to 1, and it shouldn't skip anything. So I'll just test that real quick, and there's still going to be an infinite loop. Well, that's not what I wanted to print. It should go from 1 to 40. So it starts at 1, and then it goes to 40, and then it loops. I want to make sure I got the beginning right. I want to make sure I didn't skip 1. So I have to scroll up a lot, because this is just an infinite loop, and I can't scroll up enough. So that's just for debugging, so this doesn't loop. That's not what I wanted to check. I wanted to check I, which changes, not n, which is a constant. Come on, man. What? Do I equals 1 through n? Oh, because it's this inner loop. And I want to check IT. What? What's going on here? What the fuck? IT. Oh. Yeah, that only exits the inner loop, but I want to exit the inner loop as well, or just like abort the entire subroutine. So return. There we go. So this only has 50, right? It loops from 1 to 40, and then it loops from 1 to 10 for a total of 50 horizontal moves. That's because we only move horizontally every other time step, because the even ones are vertical motion. Only the odd ones are horizontal motion. And what I wanted to check is that the first II is 1. It's not 0. It's not 2. I don't have any off by 1 errors. This is correct. So the character don't really need a separate variable for this, but why not? It's going to be the ith character of S. So we have right, we should have 3 rights and then a left. 1, 2, 3 rights and then a left. So that looks correct. Okay, one other thing I want to do, I have IX and IY to keep track of the position of the piece. What happens if the input tells us to move left, but we're already up against the wall? Well, then we move back, because you can't move into the wall. You can't move through the wall. So I want to keep track of the last X position and the last Y position as well. So I'll declare a couple more variables for that. And then set them inside the loop. So now I think we're ready to apply the motions and then try to detect collisions. Because if we detect a collision, then we have to move the block back to the previous position. And if it collides with something to the left or the right, it keeps moving downwards. But if it collides because of downward motion, then it comes to rest and it stops moving, and then a new piece gets introduced at the top of the tower. So dx and dy are going to be the motion. Oh, by the way, you can use semicolons in Fortran if you want to put multiple lines of code within a single line of text. So I think this works, and it looks a little cleaner, actually. Does that compile? Yeah, that's okay. I want to get rid of this because it should loop infinitely until it comes to rest, which I haven't programmed the rest logic yet, so this should be an infinite loop. Okay, so if it's that character, then the motion is to the right. Should I do checking in here? Yeah, why not? should loop infinitely, and it shouldn't trigger this error as long as the input. 1 through 40. What? What? What are you talking about, bro? I don't know how that happened. That's the test input. I think like when I hit Control C, something funny happened. I've never seen anything like that before. Like, am I imagining what just happened there? I got that on video, right? Okay, that is still Gucci. What the hell happened there? Is this wrong? Hold on. How is that negative? Oh. IT overflowed. Yeah. I think IT overflowed the max 4-byte integer. Shouldn't take that long to get there. Now it's just fine. Well, yeah, the other thing is I have optimization turned on. I want to turn that off because this isn't a crazy problem like yesterday where I did a brute force implementation that takes 12 plus hours to run. So well, that was kind of funny. I'm not seeing it anymore, but I think what happened is IT, because I only ever increment IT. Yeah, I think IT went to the max 4-byte integer, and then it got incremented, and it overflowed and wrapped around to a negative integer. So then I was negative, and we got like an invalid character. But we should get to the maximum n before IT overflows. So I don't think I have to worry about that once I write the rest of this code. Okay, so that's horizontal motion, and then there's vertical motion, which is just dy equals 1. And then I don't need to set dy in here, and I don't need to set dx in here because I've just set them to 0 here. So now we get to move the piece and then look for collisions. So that moves the piece. And then, yeah, so we have to add some logic for this step. The input tells us to move right, but this piece is already up against the wall, so we can't move right anymore. So basically, I haven't had to use this P array yet. So first of all, we have to keep track of which piece we're on, whether it's a horizontal line or a plus sign or what. So that needs to be another modular thing that cycles just like the input cycles. And then I'm going to have to loop through each of these and add up the coordinates to get the minimum x coordinate and the maximum x coordinate and check if that's colliding with a wall. And if it collides, we have to move back to the previous x position. So like we have II for the input index. So like we have II for the input string index, we're going to have IP for the piece index. And then that's going to increment after a piece comes to rest, or like before we generate a new piece. So it's inside this loop, but it's outside. Wait, I don't need that. It's just I. I don't need a separate variable for this. Okay. But I do because it's modular. So it's mod I. We have to keep track of 1 has to stay 1, but n cannot turn into 0. So we have to subtract 1. And then what is this? Yeah, np is 5, the number of pieces. There are 5 different shapes. There's horizontal, vertical, plus L and square. That's 5. So np, we have to subtract 1 inside and then add 1 outside. So that's going to convert I to something in the range of 1 through np. So IP is going to be something from 1 to 5, inclusive. Now, actually this is a rank 3 array, so that's kind of a lot to keep track of. Let me be conservative here and just get a whole big block of text. I want to look at this code while I'm writing other code below. I think I can put it over there and you can still see it, because over here you're covered by the webcam, and I know that. I can see the screen there, but I know that my webcam is blocking that view. So, where was I? Yeah, here. We have to check for wall collisions. So we're going to set xmin to the first x coordinate. So it's going to be p, that's 1 for x. And then 1 for the first block in the piece, and then IP for the current shape that we're on. IP is going to vary from 1 to 5, so it's going to vary from a horizontal or plus or L or vertical line or a square. And I might as well, yeah, I should get all 4 bounds at the same time. So max is the same. Then we also want y. But for y, this index changes because the first index of p is 1 or 2 for x or y. So I have to change those 1s to 2s, but I want to keep this 1 as 1. So that's the initial bound, and then we have to loop through all of the other blocks in the piece to see what the other bounds are. I think I can't use I. I'm already using I here. So now I'm going to use J. And then it's going to loop for some of the pieces have 4 blocks and some have 5, so I only want to loop to that upper limit. NBP IP, so that's going to be a maximum loop index of 4 or 5 depending on the piece. And then min is the min of that, so we're going to clamp down to the lowest of whichever argument it is. That's going to P1 for X, J for the current block of the piece that we're iterating over, and then that. So I think that's right. Then we have to do the max as well. Just trying to think about dry. So you could have a nested loop here which loops over X and Y, and then like you wouldn't need this code, you could get rid of those 2 lines, but then you're going to add 2 lines for the start of the loop and the end of the loop. So it doesn't really save you lines of code. And the dry methodology says don't repeat yourself more than twice, but repeating yourself twice is okay, at least per the standards of dry. So I'm okay with a little duplication here to change all of those things. So I think that's it. Then, yeah, I think that's it for the bounds of the piece. So now, like for this piece, it would have X min here and X max here, and then it's a vertical line, so Y min is Y max. Those would both be the same value for this piece. But for the square piece, Y max would be 2 plus Y min. So that's how that works. Do I need Y min and Y max? I don't think so. Do I need these bounds at all? I think I have more code here than I'm going to need, but I'm going to leave it in rather than delete it because maybe I haven't thought of something and I'll need it later. But I think getting the X-min and the X-max bounds are the easiest ways to check for wall collisions. Because for vertical motion and collision with another piece from horizontal motion, I'm going to have a separate check for that, which is not this bounding box check. It's going to check, if the piece is concave like the plus sign, then the bounding box doesn't work. There's going to be another check that I haven't implemented yet. And then this is going to be somewhat redundant, but this is going to be good for the wall collision check, so I'm going to leave it in. So if X-min less than 1, then I'm just going to reset IX to the previous position. We don't have to change Y because the only way we could overflow a wall coordinate is from horizontal motion, so we don't need to reset Y. But you could just be safe, but it's not going to do anything, or at least it shouldn't. And now, I think I have to check for a piece collision. going to be similar to this loop, but I don't need bounds. I'll just call this x and y now. They're integers, not real coordinates. And it's not a min. It's just that thing from the, oh, I forgot to add. So I have to be adding, ix and iy. Because this array, this is like local coordinates, but then the corner of the piece moves, so I have to add the corner of the piece. X, x, y, y. Yeah, I think that's right. And then we're going to check for collisions with other things by looking through this rocks array. Also need to check for a floor collision for the first piece, or like the first two pieces. Like if, no, I think it's impossible. It could only happen for the first piece, because if this piece falls first, is this 7 wide? Oh no, it could happen for a couple times. So like the first two pieces could collide with the floor at the very bottom instead of another piece. So we're going to check for this by looking at the rocks array, which I think I have to initialize. Yeah. It's already allocated. It's a statically sized array, so I don't need to allocate it dynamically. And it's going to start out as empty, and I have this parameter empty 0. But saying rocks equals empty is more readable than saying rocks equals 0 literal. This way you avoid magic numbers. That's the way I like to do it. I need a coffee refill. Alright, I'm back. Yeah, so I've initialized the rocks array. And now I have to check if this is colliding. So if then I need to do something. I don't want to say rest, because vertical motion cannot cause the piece to come to rest. It just doesn't do the vertical motion. So I need a separate logical variable. I'll call it collide. So did I spell that wrong? Okay, there we go. Spelled it right now. I wanted to make sure I didn't have that same typo anywhere else. So you could do it like this. That's like 3 lines of code, but I think that's equivalent to that. So I think I can save a little bit of code that way. And then I think this, you don't need to do this block multiple times. You can just check for collisions once at the end. but we might need to reset X or Y. I need to keep this logic somewhere else. We need to reset IX and IY. And then if it's collided due to horizontal motion, that's fine. We can keep moving the piece at the next time step. But if it's collided due to a downward vertical motion, then that means the piece has come to rest. There's no upward vertical motion in this game, so you can't have something moving up in the Y direction. But so it's against the rules to begin with, but if it were allowed in the rules, then I don't think that would count as a piece coming to rest. So we're going to say if there's a collision and it's due to downward vertical motion, so dy is less than 0, then the pieces come to rest. I'm going to OR it with that just in case. I don't think that's necessary, but I'll leave it in there for now just to be safe. And I'll probably never take it out later because this is advent of code, and I don't really. How long is this already? This is 200 lines so far just for part 1, and I'm not even done with part 1 yet. So I don't really have the time to do this every day and then go back and clean up the code to make it perfect and immaculate. So that might be a little bit more verbose than the code needs to be, but I'll probably leave it in there and never take it out if it's correct. What? Oh, yeah. I need to check floor collisions. So it's going to be similar to the wall collision. Tab completion keeps biting me because I say collide or collision, but then the variable is named collide, but it completes to the other thing. Okay, so yeah, that was helpful. I probably don't need Y max for anything. Or do I? Yeah, I need Y max to know when to spawn the next piece. So I want to change this a little bit, because if the piece has come to rest, then I want to update this variable, which determines where the next piece spawns in the Y coordinate. So do it like this. We still have to set rest equals true, and then Y max rest equals Y max. So I ended up needing all 4 of these, basically. You could probably, if you made the rocks array bigger, if you indexed it from 0 to 8 instead of from 1 to 7 in the X direction, and then you set the walls to something that's not empty, then you could do this to include the wall collisions, and then you wouldn't need this line of code. But this saves a little bit of memory, and this is the way I've implemented it, so I'm not going to go back and change it. Will this stop looping? I think there are almost certainly bugs in here. It probably won't even compile, but I think I have the core logic in place. Yep. Is there anything else? That's not good. Okay, so if there's a wall collision here, I'm not resetting it before I check for the other collisions. So rather than add logic to skip the other collision checks, or to like check the bounds inside this loop, I think I want to just pad the rocks array. Like I said, I wasn't going to do to save memory. I'm going to pad it just so I don't have to change the rest of the code. And then I think that shouldn't happen anymore. All right. Is that part 1? Okay, getting rid of that comment just so that line's not longer than 80 characters. And that's not isum. I'm not even going to use isum. It's going to be ymax rest. Is that it? Nope, that's not right. Okay, now it's time for debugging. Oh, I have to set the rocks. So when a piece comes to rest, I have to fill up this array so that future blocks don't collide with it. So I think it should be like at least 4, even without the rocks check. I think I've got multiple bugs in here. But the first thing is I need to fill up the rocks array when a piece comes to rest. So I need to loop again, unfortunately. I'm sure you could do this without copying and pasting so much code everywhere. But this is quick and dirty for the advent of code. I want to fill this with one of these parameters, which is actually going to be IP. Right, because IP is 1 through 5. That's not right. So this is not right. Now it's time to debug. Probably this. Yeah, this is still the test input. Basically, I need to start printing out this stuff to see where I've gone wrong. To start out, I'm not going to print every single leftward and downward step. I'm just going to print out when the piece comes to rest. Maybe I want to make this allocatable. Because for a subroutine, it's just easier if the argument is allocatable. And then if the W argument is allocatable, I think Fortran is going to tell me that the actual argument has to be allocatable. So that should complain. Yeah. If the dummy argument is allocatable, then the actual argument is allocatable. So what that means is this is the dummy argument. This is the local variable within the subroutine, and that's allocatable. The actual argument is where I call the subroutine, so that's rocks. And this actual argument is not allocatable. It's statically sized right here. So I need to make it allocatable. Trying to do fancy text editing. There we go. And let me put this on the line above for consistent style and capitalization. Okay, that should compile. Nope. Not a scalar. Okay. Now I want to actually print it. And I probably want to stop soon. Don't want to do 100 pieces and then have to scroll all the way up. So, I'm going to loop backwards in Y. But I don't want to print out the top of the array because this thing is huge. Right, this is like 16,000. Yeah, 16,000 or something crazy to start. So I don't want to print all of that. I just want to print where there's actually stuff in the array that's not empty. So we start at the top of the rocks array and then iterate downwards because I want to print it in that order. I think they're off by one error here. I don't really need to print the floor because I've started indexing it from 1 instead of, or from 0 instead of 1. but I don't really care about printing the bottom one anyway. Is this a thing? No. You want to skip the walls. So +1 for the left wall, and then for the right wall, -1. It's a string. Don't put a new line. Advanced no. Print a new line at the end of the row, and some extra padding. Is that right? Well, that didn't print anything. Oh. Yeah. That doesn't look right. That's overly complicated. Don't need a while loop. That looks terrible. How did I end up with a diagonal piece? Wow. I was about to say something about my job, but I'm not going to talk about that publicly. Keep it focused on the advent code. So, yeah. Just a couple minor typos. No, there's more than one typo. 2 for Y. Hey. Okay. Is that right? Yeah, we have that piece there. We have the plus sign there, and we have this empty space on the left side. So the left side of the plus sign is aligned with the left side of the vertical line. And then where does this reverse L end up? The reverse L ends up in the wrong location. So the reverse L should end up here, but it doesn't. I've already fixed one bug though. I want to do this afterwards. Right? let's do a couple more. Something is off. Where does the piece? Okay, I think this is the off by one error, which I mentioned almost at the very beginning of this video, where what happens is this piece, it falls one unit, it moves, then it comes to rest. I'm okay with that part, but then a new rock begins falling, and it's here, and it hasn't moved. So at this time step where we introduce a rock, no, should be okay. I have it right so far, so maybe it's not that error. I was thinking that like I'm off by one when a new rock begins falling and like nothing happens other than introducing the rock here. But then it immediately gets pushed left. So I don't think I'm missing any logic there. I'm not going to bother drawing this yet, but I just want to print some more stuff to say whether it's down, left, or right. Right down, right down, right down, left down. Right, down, right, down, right, but nothing happens. And I'm not printing anything for that. Down, left, down. So that's the first rock. This is printing the floor. So this is the floor, this is not empty space. I don't think it really matters. My final answer might be off by one, but right now I'm off by way more than one. Then a new rock begins falling. Pushes left, then down. I'm saying down, they say falls, same thing. Right, right, fall, down, left, left, fall, down, right, right, fall down, and then it collides. And this is correct. So that's correct so far. Then we have a new rock. Right, down, left, down, left, down. Right, left, left. So the L should start here. So it moves right. And if we look at just the minimum corner, this corner moves from there to there, right, down, left, down, left. What? What? How? Right, left, left. Am I off by one somewhere? So they have this piece moving one more place to the left than I do. Because I have it coming to rest like this. They have it coming to rest like that. Which is one piece to the left, and then it doesn't collide yet, so it moves another piece down as well. It moves another block down. It's the left that I'm missing. So I think I'm going to print this again. 12, 13, 14. What's the input? I can break it 3. I don't need to break it 5. Because this is where I have the problem. Yeah, 11. Look at column 11. My text editor Vim shows the column 11 there. So left, left. Right, left, left. Right, left, left. Is it the, is my initial Y off by 1? It's not that. Is it off by 1 in the other direction? It's not that. Then the second piece is messed up. Right, 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 left. Right, 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 left. Left, right, left, right. Left, right, left, right. And right, left, left. Right, left, left. How are they getting an extra left motion? was thinking about the padding with zeros. Because the first piece is a 4-block piece, and then this ends up correct. I have to debug this by hand. This is how the third piece spawns, right? There are 2 spaces to the left, and there are 3 spaces below the bottom of this block and the top of that block. So that's how it starts. And then it moves right, down, left, down, left, down, 11, and then it would move left if it had any more time to move. Okay. So it moves right, moves like that. It moves down. And then it moves left. And then it moves down. Of course, my problem starts when the example stops showing it step by step. Left, down. So I have to do this by hand instead of just reading the example. Left. And it hasn't collided yet. Okay. Yeah. So somehow I'm detecting this as a collision. Which implies that like I'm starting like this instead of like this. So right, down, we go from 3 spaces to 2 spaces. Left, down, we go from 2 spaces to 1 space. Left, down. And at this point, it's not colliding yet. It's about to touch, but it's not overlapping yet, so it's not colliding. Which implies that this part is wrong. I initialize collide as false. That's not right. I know what it is. We get the Y max here, and then we check for collisions, and then we reset the Y position, but we don't reset Y max. And then Y max rest here is wrong because this Y max hasn't been reset, and then this piece spawns in the wrong place vertically. I'm pretty sure that's it. So you could do this whole loop to check again, or no. I'm printing 1, 2, 3, 4, 5, 6, 7. Oh, what the fuck? Now the plus sign is in the wrong place. Doesn't need to loop like that. So I initialize them to the first, and then I only need to loop from 2 to the end. That shouldn't do anything though. Should just save a little bit of computational time. Is it like that now? Nope. right, 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 left, right, 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 left. And then it comes to rest in the correct position. Then we have left, right, left, right, right. Left, right, left, right. And then it comes to rest. Why is this one wrong now? The first one is right. The second one is wrong. What the fuck? I have this one correct again. But now this one is wrong. I have some off by one error somewhere. And if it's a horizontal motion, then dy is 0, and this doesn't do anything. That's totally wrong. It's the same as what I had before. struggling now. This shouldn't be that hard. Where are my zeros? Okay, I only have zeros in the padding positions. 4, 5, 5, 4, 4. 4, 5, 5, 4, 4. That seems correct. Right, 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 left. First piece is correct. Right, 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 left. That's correct. The second piece is correct. And then what happens with the third piece that makes it different? Am I initializing this correctly? Should be the same. Yeah, that's not right. This is so close. I don't like what I did here. I think it's behaving the same, but it should be like that. What? No, the plus sign is in the wrong place. I thought it was correct for a second, and I was like, what? I already tried this. The second piece is wrong, and that's worse than the third piece being wrong. I don't know about these semicolons. Shouldn't do anything. Yeah, it doesn't do anything. Let me set dy to 0 just to be safe. Oh, this backed up here. Again, this shouldn't do anything. And that shouldn't do anything. The second piece is still wrong. I want to or collide with itself. Because if any one of these is true, collide should end up being true. I don't want to set it true for a wall collision and then set it back to false for a floor collision, so I or it with itself. What is going on there? Okay. Sorry for pounding on the desk, it's just a nervous tick that I have. Probably sounds terrible on the mic. Okay, so basically the floor is 1. This piece comes to rest at 2. So y max rest is 2. And then the next piece should spawn at y equals 2 plus 3, so y equals 5. Is this right? I feel like this isn't right. 2, 3, 4, 5. Second piece is right now, but the third piece is still wrong. So if there's a collision, it goes back to the previous position. And then downward movements cause the rock to come to rest. I don't think I'm missing anything in the problem statement. I feel like my floor collision check might be off by 1. But if I change it, it crashes here, so I need to skip this if there's a floor collision. I just need to skip this part if there's a floor collision. Now several other things are off by 1 now. So I need to undo some of the other stuff that I was messing around with. So start that at 0. Then shouldn't subtract 1 there. Ugh. So the first piece is wrong. First piece should settle like that. Doesn't seem right. This should not be so difficult. I don't know why I'm struggling so much. I think I'm burned out on Advent of code. I don't understand how my logic can be correct for the first 2 pieces, but not the third piece. Why does it start as 2? That's 2 after this comes to rest. So it's 1, and then the first piece spawns correctly. So the floor is at 1, and now the floor becomes 2. Do I have the shapes wrong? I mean, the shape looks correct. Grasping at straws here. IP 1, 2, 3. block piece, 5 block piece. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So for the plus sign, the minimum corner is here and it's empty. Just want to comment that assumption. That really doesn't feel right. Then why is the second piece wrong? Come on, there we go. I shouldn't have to pad this for the walls and the floor. Then this is guarded by a collision check, so it shouldn't crash if it collides with a wall now. But this, the first piece is wrong now. I'm just not printing. And the first piece is wrong. Should be there. What's that? That's too many moves on the first piece. First piece is right. The second piece is wrong. Left, right, left, right, right. Left, right, left, right, and it comes to rest. Maybe I should have been debugging the second piece instead of debugging the third piece. So I'm gonna have to take a lunch break soon. How does that happen? X, saying dimension 1, so X is 0. If X is 0, collide should be true here, and then it should skip this block. How is that happening? That's not right. Where was this crashing? Okay, it was crashing on the L piece. So the horizontal piece, the plus piece, and then it crashes on the L piece here. This is the same, right? All right, X and Y both seem wrong here, because if X is in the range from 1 to 2, how does it become 0? Then how is Y in the range 1 to 8? None of my pieces are 7 units tall. Oh my god, I forgot to add. Holy shit. Wow. Did I spend like an hour and a half just for that bug? That's embarrassing. I really hate video editing, so I'm not going to edit that out. If you're still watching, congratulations, because I don't know how you sat through like 90 minutes of me adding here, but not adding here. Oh, that's embarrassing. Well, let's see what happens for part 1 now. I'm sure something is off by 1. I don't want to print all of this every time, because that's going to take forever. It takes forever just to print. It'll be a lot faster without the printing. This is probably off by 1 or off by several. 3. Oh, it's off by a lot. So let's debug a little more. Let's just check a couple more steps. No, that's not right. Things are like overlapping with each other. Okay, so we know that's good. That's good. I think that's right now. That looks correct. And then that looks correct. And then a square piece falls on top. That's correct. Let's do 2 more. So I just looked at that one. That's correct. Then we have a vertical line. That's correct. And then a plus sign. I'm not looking at the bottom. Let me check like every row of this instead of just looking at the top row. And let me add some pipes and floor, just so that it's visually exactly the same as the test. So there's a pipe. There's a pipe. Actually, okay, 2 lines. And then at the bottom, this is just static. Here's a funny thing. The default formatting, when you print a string, it pads it with a single space on the left. So if you want to suppress that space, you can't use the default star output format. You have to print a string explicitly, and then it doesn't print the space on the left. So that row. 4, 2, 2, 1. I'm just counting the number of hashes in each row. 2 with a gap, 2 with a gap. Is that 5? That's 5 in a row. Then 3, 1, and 4. So that's correct. Let's do another 2. 2 more before we return early. That looks correct. I'm not going to check every row for that. That looks correct. How am I so far off at the end? N is 2022. I'm on the test input. Of course I'm on the test input, like everything I just checked was for the test, so that better be right. How tall is it? So that's just the height. They don't want to know like how many hash marks are in here. They just want to know like the Y dimensions of it. 3068. Let me make sure I get all of my return statements out. Those are all the returns. Any exits just in the reading, any stops just there, but it should print an error if it does stop early. Again, I don't want to print all of these. How is this so far off? "2022 rocks." That means 2022 pieces. So I set this loop upper bound to 2022. Let me stop it at 3, just to make sure that's the same thing. And let me print the rocks. That's the first piece, second piece, and the third piece. So that's 3 rocks. And then if I do 2022, which is n, did I like accidentally? N is a parameter, so a parameter in Fortran is like a constant in C. That means it cannot be changed. It's 2022. With the debugging. Just that should be faster. It's unused because I commented it out. Out of coffee again, but that's all the coffee I'm gonna drink today. It's too slow with the rock printing. So what was my big mistake here? My big mistake from the last bug that I fixed was that I forgot to add something to P. So let me search for P. It's adding stuff there, IX, IY. It's adding there, IX, IY. IX, IY. ix, iy. I don't understand how I have like all of these steps correct. And I'm so far off at the end. Oh, is this 9? I can exit the loop there instead of returning from the subroutine, and then it should get to this and print. That's more than 9. Plus 1, 2, are these 3 more pieces? I think it was 11. Didn't I check this before? It's 1 too many, it's 10, I guess. Okay, so this shows the first 10 rocks. This is the height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. Let's already have that open. Paste that so I can count the lines easier. That's 17. Oh, okay. You could have everything collected on the left side of the space, and then your final piece could fall down on the right side and end up much lower than the top piece. So y max rest here, y max rest is wrong because this is the last piece, but I want the highest piece, not the last piece. So I'm going to call that y max max, for lack of a better word. I'm not going to waste time naming things precisely. And then this doesn't spawn relative to y max rest. First of all, that line is entirely wrong, so I'll just delete that. This spawns relative to y max max. I don't need that plus minus 1, so I'll delete that. So that's the top of the last piece, and the top of the highest piece is going to be the max of all of those. It's called y max max because it's the max of the max. That's why max is twice in my variable name. I think that makes sense. Maybe somebody else who looks at this code wouldn't think that makes sense, but that's how I name things. And then answer. So like right here, I guess it's this square piece is the last piece to fall. So that ends up at 14, but y max max should be 17 there. Or I might still be off by 1, so it might be like 16 or something. Not what I wanted to do. Okay, that's 17. And now let's run it for everything, all 2022 rocks, which is just N. Come on, Vim, just N. 3068, let's go. And let's do that on the real input. That better be Gucci. Get in. That's part 1. I think I'm going to take a lunch break after I read part 2, and then I'm going to think about this over lunch. That's a lot of rocks. I think I can do this. I might do this right now because I think all I have to do is change some of my integers to 8-byte integers from 4-byte integers, because that... Am I going to have a memory problem here? I'm going to have a memory problem here because I can't allocate an array that big. But you don't necessarily need to keep track of the bottom of the array. At some point, like here, for example, there's not an entire row that's occupied, but, oh god, I lost my place. Where was that? Okay, like here, for example, there's no single row that has every spot filled, but in these 2 rows together, they block everything. So a block can't fall beyond here because there's no way I can sneak through. So here I could reallocate my rocks array. The rocks array is going to be the problem because I'm allocating it to the max height. But after, what is this? That would be 1,000, million, billion, trillion, a trillion rocks. A trillion rocks is going to take like a terabyte of memory, and more than that, because a rock takes up more than 1 byte. So I can't have this array be a trillion units high, because I don't have that much memory. Almost no computer. There might be a couple supercomputers in the world that have that much memory, but I certainly don't have that much RAM. So I need to not use this whole array. I'm going to have to use like the top section of the array that's not blocked. Yeah, so that's going to be the tricky part of part 2, memory management. So with that, I'm going to take a lunch break. On second thought, I'm now expecting that part 2 might take me a while, if I can figure it out at all. It might be more tricky than I'm guessing at this moment. So I'm going to attempt that as a second video if I figure it out at all. So that's all for now, and I'll catch you next time.